Okay, good morning, everyone. We're going to get started a minute early. I'm going to hopefully have a little bit of time left over. Without further ado, my name is Bill Bliss. I'm one of the founding members of Microsoft Teams. Little trivia, I was also on the original Outlook team, so as I like to say, I'm disrupting myself. Anyway, today we're going to talk about Microsoft Teams architecture. And so how many of you have seen this before or versions of it at other sessions? Okay, a few of you. So hopefully it won't be too repetitive. I've put in a few new things to update here. So let's start with the high-level client and services architecture. This is kind of the 10,000-foot view. And we're going to go into detail on each of these boxes, and they're going to be color-coded consistently. So at the top, we've got the Teams clients, of course. On the left, you see the Office 365 platform and services. In the purple, bluish purple, you see the Teams services. The Intelligent Communications Cloud, that's the new name or new-ish name for what we used to call the Skype infrastructure. It's the same thing. And it's a set of services that we're going to go into. And then at the bottom, of course, everything runs on Azure. So let's look at the client architecture today. And I'm not going to go too much into what it will be in the future because we don't really have time, but I will allude to some of the changes that are coming on the client here. So on the left-hand side, you see the desktop, and on the right-hand side, you see the mobile architecture. But both of them are optimized for agility, and they auto-update. So little known fact, it's fairly well known by now. How many people have heard about the concept of rings, release rings? A lot of people, yeah. So what that means in practice is that the bits that you're running on your desktop or your mobile device actually have features in there that won't see the light of day, maybe ever, hopefully not, but maybe for months or years. So for example, private channels, the feature that we announced this week has actually, we've been using it for a long time. You actually have those bits on your machine, it's just they're all turned off and controlled by flags. And no, there's no way to turn them on. But anyway, without further ado, so the desktop, you've got the web, and that's based on HTML and CSS, of course. Angular moving to React, that's what I was alluding to in terms of the code base is moving slowly but surely over to React. There's actually React bits in there right now. Underneath that, we've got a zillion different libraries, jQuery, Lodash, the usual suspects. And at the bottom, the client is completely written in TypeScript, transpiled to JavaScript, and we use Node. There's actually the desktop version the web version doesn't use Node, but the desktop version does, and that's actually how we implement some of the calling and meeting features. It's written in C++ or Objective-C for the Mac. But at any rate, and that is all wrapped in an Electron wrapper for the desktop client, and that's for Windows and Mac. And so that's why what we do is Electron is a technology, open source technology started by GitHub, but now used by a lot of different companies. VS Code uses it as well. And basically, it's a way of taking a web-based app and wrapping it in an executable. And there's some native code, as I mentioned, in C++ and Objective-C. On the mobile side, the iOS client, the same client, the same bits are used for the iPad and iOS or the iPhone version, and that's written in Swift. And Android is written, of course, in Java. And at the bottom there, you see a little bit of React as well. There's a few bits of React Native in there as well. One of the reasons of moving to React is that we can actually have a more common code base across our clients instead of writing it 3 times. 4 if you include Graph, which I'll talk about in a little bit too. So what's in the team services? So I'm not going to go through all of these things, but basically they're kind of roughly organized into identity, the team management and the administrative interfaces, of course, all the compliance features, information protection, things like that. The extensibility, the team's platform, that's the team that I'm on actually, is over over there too, tabs and graph and bots, things like that. And the notifications and the email service, and by email I mean the ability to email a channel. That was also my feature, by the way. Particularly proud of that. But at any rate, what you may hear occasionally will refer to the team services, the middle tier. And that's because it was originally written as a monolithic piece of C#.NET code, but it is actually now broken up into microservices so that we have more agility in deployment and we don't break things inadvertently. It also gives us the ability to scale up and out because not every service is used equally. Again, we have a similar rings type system for this code as well. It's not exactly the same, but again, we have code that is, again, pre-production, not in the public yet, turned on there. See, the IC, we always call it IC3. I always have to remember what the C's stand for, but that's what it's spelled out, Intelligent Communications Cloud. But anyway, that's where the messaging and the calling and meeting and the people service, the configuration service, and identity. So briefly, what these are the next generation, the evolution of the Skype services that we use for messaging and voice over IP calling. This is where the PSTN, the telephone network integration code is, and that's also uses the Skype for Business online stack. It's the same thing here. And then there's unified presence, which we'll be talking about in more detail later, but this is actually how we do presence both within Teams, but also across Skype for Business and Teams clients. Briefly though, the messaging stack is all the things for handling messaging themselves, but also media, meaning when you paste an image, that goes to a separate service, blob storage. Search is there, and we're rewriting search. We're working on it. We know it's not where it needs to be. URL preview, that's the little thing that when you paste in a URL, we go and crawl it just like Facebook does, get the extract and put a little link there. Notifications are there. The personal expression service, that is basically things like emoji and I guess you would include some of the stuff for stickers and stuff there as well, although a lot of that's on the client. The calling and meeting stuff is a very deep stack. We'll be talking about that more in a little bit of detail later, but this is all the related things for voicemail and call recording and of course the calling service itself, meetings itself, meetings as well. People in presence, we talked about that. The experimentation and configuration. This is actually the service that controls all that ring stuff I was talking about, but it's also how we do A/B testing. So at any point in time, we are actually experimenting with different pieces of the UI, different experiences to see which one works, which one's most effective, which one has the most impact on engagement and usage discovery, things like that. And so that same service controls that. The identity service, Skype Identity. Skype, as you may know, is obviously used by the Skype consumer client, but also on Xbox when you use Skype on Xbox. And so it actually has its own token service, and that's what the identity service is. And so all of our services actually use a different token than the AD token for authorization. So let's look at Office 365 and where we fit into that. So on the right-hand side are the usual suspects when you think of Office, things like OneNote, Power Apps, Planner, and of course PowerPoint, Word, and Excel. But on the left-hand side, of course, is the platform side of things, the Exchange, or the services that Teams is based on. Exchange, of course, for email, and the calendar. The calendar in Teams is the same calendar on Outlook, and we use Graph to retrieve that. Modern groups, also called Office 365 groups. I think that's actually the name in the hub over there, so maybe I should change these slides. We keep changing the names, but we call them modern groups. And SharePoint and Stream for voice recording and for media recording and voicemail. Actually, not voicemail, that's different. OneDrive for business and then information protection, of course. And on the bottom, of course, we use Power BI and all that other stuff, all those other things for our analytics internally. So we really, if you think about Teams, we really envisioned it and built it as kind of a large systems integration project, right? Because we decided to say, well, there's all this stuff in Office 365, this great set of services, great set of applications, but there's nothing that really brings them together all in one place as one application, and that really kind of makes the whole greater than the sum of its parts. And so that's what we envisioned Teams to be, and that's actually why we built it this way and why it works this way. And so that's why we call it the hub of Office 365. And that's why we didn't actually reinvent the wheel, at least not where we didn't have to, in building Teams. I'm not going to go through every one of these, but you can assume that Teams uses most of what is there in Azure. Now, actually being most is actually hard to do because there's more and more every day. We're not using quantum computing yet, but at least not that I know of. But at any rate, we're using all the things, Key Vault, blob storage, all these things that make Azure great. And really, we could not have built Teams, no question, without Azure. We offload so much of the complexity of running these things to Azure, but it gives us resiliency in the face of natural disasters, and worldwide data residency requirements is part of that because you have to have data centers there. So it's really pretty amazing. The massive scale of Azure is something that really gives us something that really is, we could not have done it without Azure. It's also worth mentioning that it's also how we deliver a lot of compliance, not just data residency, but also a lot of compliance standards that Office 365 supports relies on things like the controls you have, physical security, and who has access to the data, and is it encrypted, all that kind of stuff. And so Azure does a lot of that for us. So I mentioned data residency briefly, and why our deployment patterns are part of that. I need to actually get a little bit closer to the screen to see some of these things. So originally we started out in 3 regions in the world: Americas, EMEA, which is Europe, Middle East, and Africa, and Asia Pacific. Those were the 3 regions in Teams. And since then, we've built out a lot of what we call local data centers or sovereign clouds, depending. And so, and that's also where the US government clouds are deployed. So Canada has its own dedicated data center. The UK does, Japan does, India does, and Australia does now. And we're continuing to build more. And the US government clouds, there's 3 of them now. And those are all also dedicated clouds as well. So what's interesting about this is the implications on data residency, and it's one of the main reasons we invest in these clouds. So if a customer's tenant is in Australia, Canada, the EU, India, Japan, or whatever, or all those regions, we store the customer data at rest, meaning once it's stored on disk, within that geography. So Teams chats, Teams conversations, images, voicemail, and contacts. SharePoint online site content, all the files in a team is what that means, and the files uploaded for OneDrive for Business. And so this guy's kind of a bird's eye view. I guess you'd have to be a really high-flying bird to be able to see this view. But anyway, it's the view that, of where the data lives inside Teams. So I mentioned earlier that we'd go into a little bit more detail about the Teams client, and this is what that is. So this is one level deeper, and so you can see the Teams clients in more detail here. So one is the web client, as we mentioned, and the desktop app in Electron. And on the top here, I've added the Graph API, and it's a little bit odd to think of that as a client, but it kind of is, because we basically, the goal of our Graph APIs is to expose the functionality in the of the client as in Microsoft Graph. And to do that, it's logically a client, and we have to write it over again in some cases. These are all color coding. The purple is Teams. The dark gray is the IC Intelligent Communications, the IC3, and the Microsoft Core Services are in black. I won't go through all of these things, but basically the key point to see is that in many cases the Teams client talks directly to these services, and it doesn't go through a middle tier, right? So you can see those direct dots from, say, OneNote and WAC. That's what we call the Word, Excel, and PowerPoint web apps. Web Application Companions, I think, is the acronym. OneDrive for Business. Those are all talked to directly via the Teams clients. But then in some cases, there's some intermediate services. The purple Teams Services box that you saw earlier is one of those, of course. But also the messaging and the audio-video settings. And that's the IC3, what used to be in orange in the last one. The connectors are down there, the connectors that actually deliver things via webhooks from, say, Azure DevOps or anything else, all the other 70 or so connectors we've got. publish and subscribe, stream recording, and so forth. We're going to go into a bit more detail on that. And at the bottom is some of the microservices I was talking about, the middle tier. Graph webhook, push notifications, the Exchange email service that also talks via information protection, Exchange Online Protection. Well, actually, that's both. I'm sorry, that's information protection is the stuff for the ability for investigate or the hold for a lawsuit and things like that, and also things like data retention. The notification and the email service then talks to SMTP and then also talks to Exchange Online Protection. So let's look at the messaging data architecture in a bit more detail and how that data is stored. So the Teams client, as I mentioned, talks to a number of different services. So there's the media service for images, real-time notifications. It uses a long pole over TCP/IP. The chat service, you can see the core data structures in there. There's the message thread, and a thread is not really the same thing as it is in Outlook. In Outlook, you think of it as a series of messages. Well, in Teams, a chat message, even if it's only a single one, and even in chat, is a thread. Or rather, the chat itself is a thread, and every message is a message. And then when you have message reply chains, which is the threads in Teams, those are replies to that original message. The members of a chat are stored in what's called the roster, and then messages and the annotations to them. Things like has somebody replied? Does it have message reactions? Things like that. Those are the annotations. There's a bunch of different things beneath it for handling publish and subscribe, the email service and notifications and so forth. We're going to talk about some of those in more detail here. And then there's message sync against the aggregation service. And so that's for when you reconnect after not being, having visited a channel for a while, it goes and gets them in bulk because it has to fetch what it doesn't know about. So let's look in detail about what happens when you post a message. So here you see there's user A and user B, and we're going to walk through exactly what happens when they connect. So user device, or user A on device 1 posts a message. So what they do is they talk to the chat service, and then user B, they just logged in, okay? And they have to sync the messages that they haven't seen before, and they will see user A's message, assuming it was of relevance to them. User B on device 3, they may be active and already logged in. Like, let's say this is their desktop. Okay, in that case, they are syncing via a long pole, and they get real-time notifications over long pole, and then they get the messages that way. When a message is sent, a bunch of different things get notified, and not all at the same time. It's kind of asynchronous. So Exchange gets notified for information protection, so it can be stored and archived. The search index, of course, gets notified, the notification service, the Graph webhook, if there are subscriptions for Graph, the activity feed, the Federation gateway. So a bunch of different things get notified just as the course of something as simple as sending a message. On iOS, the push notifications get sent via the Apple push notification service. And if you're on an Android device, then of course it goes through Google. So we talked earlier about data residency. And if you go down a little bit deeper on that, you can actually see specifically where they're stored. So the chat service, most of it is stored in memory, and it uses Azure storage, blob, tables, and queues, and moving over to Cosmos DB. And I say moving because one-on-one chats and group chats are actually over in Cosmos DB already. There's 2 versions of the chat service, chat service v2, and that's actually already powering chats, and we're moving channel conversations over to them as well, and then they'll be in Cosmos. Substrate and Exchange, and I've alluded to this earlier, all the chat and channel messages are stored in Exchange for information protection purposes. and the images are stored in its own service. Giphies, if you were insanely curious, are not stored. We just store the URL. So file storage. So this is actually pretty interesting. One-on-one chats or one-to-N chats, they're stored in the OneDrive for Business of the person who posted it, and then the permissions are set so that everyone else can read it. For team conversations, they're uploaded to SharePoint, and there's a folder associated with each channel in the team. I mentioned earlier that Teams was built on top of modern groups or Office 365 groups. And so when part of the group's architecture is that when a team is created, a SharePoint team site is created under the covers, and then there's documents folder being a team site, and then there's the channel folders are underneath, the channel folders are underneath the documents. They're subfolders of the documents folder. We also support cloud storage like Dropbox, Box, Citrix, ShareFile, and Google Drive, that is also part of the file story. So this actually is a kind of an exhaustive look at where all the data is stored. Messages, images, files, voicemail recording, calendars and calendar meetings, and contacts and telemetry. And this is, we've covered a lot of this already, and I won't necessarily read it out, but the key thing is you can take a picture of this if you like, but it basically describes where things are stored and where data is stored at rest. Let's see, is there anything of interest that I haven't already mentioned on here? Interesting thing about telemetry, we record pretty much everything everybody does in Teams, but we are incredibly rigorous about stripping out anything that indicates who you are or who your company is, or what the folder is called or whatever. It's all random identifiers and things like that. And that's part of the promise that we make to you as part of Office 365. And in fact, it's so big that if we do actually leak information, which doesn't happen in the telemetry, but sometimes can happen in the error logs, it's a live site issue, and we drop everything and fix it. We're super, super serious about that stuff. So let's talk about meetings, calendar, and presence. So you might think that you could talk directly to the calendar via graph, which you can, that absolutely, and that's what we do. But we actually wrote a middle tier service as well, because we also handle interoperability for mixed mode environments and also for scheduling meetings. So it's not just enough to work, well there's two key scenarios. One is that when you're scheduling a meeting, you obviously have to get the free busy information for the other people and that kind of thing. And for that, it makes sense to cache that information. So there's a service that does that. But we also do interoperability with Exchange on-premise. So we don't advertise this a lot, and the details actually, can get pretty gnarly. But there's different versions of Exchange besides Exchange Online. You can have Exchange. There's versions of Exchange, same bits, but running on-premise or dedicated instances and so forth. And so we have some interoperability to support those scenarios. We have a service that can talk to those things. So here's how meetings work. What's interesting is a meeting in Teams is in Outlook, a meeting is an appointment item with extra properties. And in Teams, a meeting is a group chat with extra properties, right? So, and if you think about it that way, then you can actually kind of see how it works. You can kind of think of them as meeting coordinates that are shared between them. And that's the metadata that we use to bind the intelligent communication services to them, right? So it's like the coordinates of the meeting. And that's how we associate things like the phone number and the dial-in number and all that kind of good stuff. So the key thing here is, as we mentioned before, the meeting itself is stored in Exchange. And then there's a bunch of different things to handle the unique scenarios around meetings. So obviously voice and video, that goes through the media mixer service and a recording bot when you record a meeting, which we'll talk about shortly, which then goes to the media service and stream. We'll cover that in more detail. But before that, let's actually talk a little bit about messaging and how presence interop. So here's a picture of user A using Teams and user B using Skype for Business. And so on Teams, they talk to the chat service and presence, And on user B is talking to Skype for Business presence and Skype for Business chat services. And there's also a message gateway, and there's some other stuff at the bottom. And then there's user C at the bottom here too. So let's see how this works. So user A, using Teams, posts a message. It routes a message via the message gateway, and that finds its way down to Skype for Business on-premise. And then user C picks that up via long poll or a sync or a push notification. The details vary based on how it's connected and when. We set our presence in Skype for Business and in Skype for Business, and then there's a publish and subscribe system to the message gateway, and we basically use publish and subscribe paradigm for figuring out presence, and that's how that works. And then the Skype for Business client can get presence by calling its respective service that handles presence. And then Skype for Business, user B, when user B sets something, that also gets set back to the shared service. So I mentioned earlier meeting recording. This is how it works. This is actually, I think, kind of cool. So you've got user A using the Teams client and user B using the Teams client. There's a meeting service, the recorder and the media service, and of course the chat service and Microsoft Stream. We alluded to those before, but here's really how it works. So the user starts the meeting, or starts the recording. There's a call recorder bot. It actually really is a bot. It's a special kind of bot, but it is actually a real bot. And the Azure service records the call. And the recorder sends the data to the media service that does, the media service does the transcoding of the video and uploads to Microsoft Stream. And then the recorder bot sends posts a message with a link to the recording. And then user B, at any point subsequently, receives a message on the client and then can watch the recording at their leisure. Here's how calling works. And this is actually also, I think, pretty cool. And this is actually something that we've been doing a lot of work on in order to enable more calling scenarios on the web and using the web browser alone without necessarily using Teams. So I mentioned earlier that the desktop and mobile stacks were built on the web and mobile, but I didn't actually mention how they work. I alluded to Node and so forth, but this is actually how they work. So the desktop uses HTML and CSS, and the mobile uses, actually a lot of the mobile clients' UI is also that way. Anyway, it uses the calling service, and it calls this thing that we call the iCall API, and it's a client library that we wrote in TypeScript, and that's actually what is the API that we use. And the API doesn't matter too much other than it abstracts out the details of what happens beneath. So the actual bits, C++ or Objective-C or Java or whatever, is in a library called SlimCore, and that's what actually talks to the services down below. There's relays and registrar and Trouter. I love that Trouter component. I love that name. It's basically, when you're behind the firewall, how do you know someone's trying to call you, or how do they reach you, and so forth. And so it basically kind of handles that kind of routing. There's a call controller, a media controller. Call controller is the thing that says somebody's hung up or somebody's answered the phone, all that kind of good stuff. The media controller basically handles the bits, the audio-video bits that are going over the wire. And of course, there's chat service. Now, what's interesting, though, is that a lot of this, not all, but a lot of this works on the web as well. And so there's a notification stack, what we call a trap client, and I won't go into all these details, but a lot of these scenarios works over just pure JavaScript, using Chrome or Safari or whatever, using WebRTC. So this is a little bit more detail about calling, and then you can actually see some of the flows I mentioned before, things like the messages, of course, but creating a call, joining a call, and so forth, notifications that something's happened, somebody muted their mic, or somebody joined a call, et cetera. The media, of course, talks to the media services. The call controller also controls things like the roster of the call, who's on at any point in time, when you transfer a call. this wouldn't be a meeting scenario, but when somebody calls you and then you transfer it to somebody else, there's the call controller handles those details. Renegotiate, as I recall, has to do with renegotiating the connection details, like when you hang up over web and you go over PSTN, things like that. Registrar has to do with when you turn on your device, when you launch Teams, you are now a callable device, and that has to be registered, and so that other people know that you're there to call, et cetera. There's all the stuff down below around policy. I won't get into a lot of detail on that, but all of that controls things like, well, can this person call at all, and can you call them? Not everybody in the tenant necessarily can, so there has to be something to control that. And all of those things ultimately call the online services, the cloud, the Skype for Business online services that you see over there on the right. So how many people are familiar with virtual desktop, like Citrix, XenApp? Good. I was wondering whether to include this, because this is pretty pointy-headed stuff, but I thought you might be interested. I don't remember exactly when we released it. I think it was earlier this summer, but it works on VMware, VMware's virtual desktop infrastructure, and Citrix. And here's how it works. So the goal is to create a performant VDI implementation that works seamlessly for multiple partners, multiple meaning VMware, Citrix, and the forthcoming Microsoft Windows virtual desktop. So the approach is to augment Teams by injecting functionality to allow audio and video, AV for short, to be remoted. That's the whole job with virtual desktop, is you remote everything. But not everything can be remoted. Right? You can't remote the mic. You can remote what comes out of the goes into the mic, but you can't obviously remote the mic because there's no mic on the virtual machine in a server room somewhere. But also, you want to be smart about it too. If you have a smart device, you want to use the capabilities of that device. So that's what this is. So I mentioned earlier the calling stack and the WebRTC. That's the stack in modern browsers for doing online video and calling. And so what we do is there's a number of WebRTC functional overrides that we use for remoting. So there's this thing called RTC peer connection, and that's the thing that creates the connection on the thin client instead of the virtual machine that allows the audio video to stream directly between the remote client and the thin client. I'll show you a picture, so you don't necessarily have to parse all that right now. There's also mirrored audiovisual elements. So that's what allows changes in Teams that is running on the virtual machine to be represented on the thin client, okay? And then there's the partner VM implementation, which is specific to the partner, of course, and that's what contains the secure connection to the thin client that allows the virtual machine to be notified about AV events on the thin client. So that's a lot of words now. Let's see some pictures, see if we can understand it here. So this is the basic architecture. You've got the thin client or the terminal running on the left, and that's running, of course, the WebRTC stack, and that's talking to the remote endpoint using the Teams client. But under the covers, these overrides that I was talking about, they actually talk to a virtual machine process running on in the server, and then in turn, those talk to a number of different services. But the key thing to notice is this picture there, the thing in orange. That is basically remoted. There's a version of that is running in the server. And you'll see why in a second. But you can kind of think of it as a version of that meeting. Everything that a user is seeing is running on the server. And you'll see exactly how that works in a second in some pictures. Now, one interesting thing to know about, and this is pretty important, is that Teams on VDI is packaged as a special MSI image. Okay, and the reason why is because it's different than the Teams client. It's different than the web client. It's kind of and it overrides certain things. So it's packaged as an MSI. So if Teams is already installed via an executable or MSI or Office Pro Plus, it needs to be uninstalled first. But basically what you do is you download that image, and 32 or 64-bit, and then you use some PowerShell commands to install it. Now the updates currently, we're working on this, are manual. You have to uninstall and then repeat the installation steps. So there's some extra things to handle there, but again, there kind of has to be because it's not like you can, you've got a virtual machine to worry about too. So you want to have that be kind of a controlled process. So the implementation details of this is it uses, as I mentioned, the WebRTC. And so if Teams is running in a VDI environment, WebRTC calling stack is used instead of the native Teams calling stack, right? So even though you're using native, what looks like the desktop, because it is the desktop, it's actually using WebRTC instead of the C++ or Objective-C thing that you would normally use. So there's you don't need to, there won't be a quiz, but there's 4 functions that are overridden. One that creates the connection, gets the user media shim, that's for basically handling media. All the media stuff is remoted, as you'll see in a little bit. There's a devices shim, and by that I mean you've got a mic and a camera and so forth, and there has to be kind of a wrapper around that to kind of handle this remoting I was talking about, and then the display media to display that back again. So these flows, it's not just about meetings. It also works for multi-party calls and call escalation, one-on-one and call escalation. So, and we don't need to go into too much detail there, but we actually use the meetings infrastructure for that as well. So this is basically how it works. So you've got the virtual machine on the left and the thin client on the right. And you've got the peer connection and its RTC peer connection, the real-time communications peer connection, and those things send events, and there's functions that handle them and so forth. And so those things are connected to each other. All the audio elements, meaning things like things that generate sound and is the microphone muted, all that kind of stuff. Everything having to do with audio is handled via a series of objects that are designed to remote that functionality. And then video, similar things. Is it hidden, paused, things like that. Those are all remoted as well. And so basically the idea is to move things over from one to the other. And then there's the ability to enumerate devices. Does it have a mic? Does it have a camera? How many cameras does it have, et cetera? All that stuff is handled as well. Of course, the thin client is the one that actually knows about the microphone, the camera, and the miscellaneous, and any other devices. And everything else is remoted over to the virtual machine. So there's some interesting stuff here. So like here's what happens. This is a screenshot. Like what happens when you hover over somebody's name and you get a window that pops up. That's an occlusion that shows up over the image, and that has to be represented, and the server has to know that this is happening. It doesn't know, it knows that there's something there, and it has to represent it. So all that stuff has to be done. And even other windows can create occlusion scenarios. So for example, if a window is moved on top of the Teams application when the video is being rendered, and it's up to the VDI partner implementation to keep track of these things. The Z order, what's relative on top of, what's on top of everything of what. And even Teams notifications have to do that. So there's a lot of interesting stuff that has to happen to make this work, but we're pretty happy with it. There's some number of things that don't work. If you think about it, and it makes sense. Things like app sharing doesn't work because the app isn't really there on the virtual machine. Give or take control, background blur, and there's a number of other things that don't work. Some of which we might be able to get to, and some of which are physically impossible. Briefly, this is what we talked earlier about the compliance boundary. I think I mentioned a lot about compliance, but the boundary specifically is kind of conceptually, it's the layer around, well, there's 2 ways to think about it. One is kind of the layer, the box around your tenant that is your information and things are safe and compliant within it. But there's also one conceptually around Teams. And so I'm not going to go through a lot of detail on this, but there's basically a lot of stuff for you've got the user and the browser and the guest users and all those things. Well, clearly they're from outside the compliance boundary, but they talk to Teams, and that is bidirectional. So those gray arrows are bidirectional. Data flows both ways. Connectors are different. It only comes in, which is good if you can do it. Email a channel is the same thing. Email, you can never send email, or you can never send email. You can never send information out over email in Teams. With Giphy, those are things where We query Giphy, and so clearly as you type a query, Giphy sees those query strings, which is why we allow you to turn it off. Push notifications and other cloud storage, URL preview, obviously, that's information sent from Teams out to the cloud. Things like tabs and bots and the Graph API and calling, those are bidirectional. Information goes back and forth. Makes sense. Just like a tab would be in your browser tab, similar idea. Information protection, I mentioned earlier how this works, but basically we continually push all the messages into email, into one-on-one chats and group chats and the channel messages. The channel messages go to the mailbox for the Office group. All the files go to, depending on which it is, SharePoint, OneNote, or Wiki. And so all the security compliance data, information protection features of Office in that panel work against SharePoint and Exchange, so everything works against Teams as well, and without any modifications. So that's it. There's some slides here. We've got a few minutes left for questions, and there's some helpful links for more information. And with that, that's it. So we have a little bit of time for questions, and if you come up and use the mic if you can, so other people can hear you, that'd be great. First gentleman to the question.
Hey, good morning.
Good morning.
So, in the compliance table you showed, what happens in a hybrid scenario where you've got online, Teams and what we're using Exchange on-prem? My understanding from your slide is that the data for Teams is discoverable because it's going to exist in the group mailbox on Office 365.
Yes.
What else? Is there any other data that's important that would not, be discoverable from O365?
So the details on exactly how the information compliance stuff works differs by what flavor of Exchange you have. The channel messages are stored in the online
Yes.
Version. Depending on the version of Exchange, I don't think the compliance. I have another version of this deck where it actually lays it out in detail. If you come by the platform booth, maybe I can dig it up for you.
But it's two searches, basically.
Yeah,
But no data is
correct.
lost.
Right, correct.
Okay. All right, good. Thanks.
Okay. Yes, sir. With the red hat.
Red hat. Okay. Bill, we've set up a lot of teams, and over time we need to change the name of the teams, and that affects a lot of things that are attached to that. How do we? Is that something that that the system will help with, or is there? Who should I talk to about that? So when we change the name of the team, right after the fact.
Well, it shouldn't. Are you talking about? It shouldn't break anything when you change.
I'm talking about all the links, like the OneNotes and all. Right?
Yeah.
So we've got OneNotes attached to it. We've got the SharePoint on the back end. There's links involved there. So when we change the name of the team, there's a lot of activity happening around a team that just changing the name, we need to make sure stays consistent.
Yeah, and that's a good question. I'm not sure what breaks when you rename things, actually. I think most of it doesn't, but I think some of it might.
We're running into some breaks. That's what.
Yeah, that's a really good question. I don't have a great answer. It's probably something we need to.
Who should I come by? I mean, who should I talk to?
Yeah, come by and talk to us at the various booths and talk to us about it. Yeah. I'm sorry? Oh, okay. Oh, great. Okay, cool. Can you talk to him? Sure.
Where exactly are the Teams contacts stored in Exchange? It just said broadly Exchange, and
I didn't hear the question.
where are the Teams contacts stored in Exchange exactly?
Good question. The contacts. Yes, the contacts are your Outlook contacts. Yeah.
Okay.
Sorry. Here, I have a question.
Yes.
I have two questions, to be honest. The first one is, do you plan to have a better way to manage multi-tenant authentication in Teams? Because today, if you have, for example, 36 or 30 customers or I think services or something like that, you have a long list of tenants that you can switch.
Yes.
And the switch is, I think you have different behavior between
Yeah.
the web client and the desktop client. It's complicated.
Yeah.
And also for development, this is my second question. For development, it's complicated because in web, with the web, I think experience, I think it's good because you are in the web and you can use the BRK token and you can move from private discussion, I think a channel and something like that with bot or other development with no issue. But in desktop application, you need to re-authenticate the user. It's not the better way. This is my two questions today.
Okay, for the first one, yeah, I don't know of any specific plans, but we've heard a lot about multiple tenant scenarios, and especially people that are actually administrators of multiple domains, or multiple tenants. That'd be something, I don't know if there's any specific plans, but I know we've been hearing a lot about it. So you can come by and talk to us at the booth. The second one, I wasn't quite sure I understood the question though.
Basically, you have a bot, for example, you develop a bot or apps.
Yeah.
If you are in the web experience,
Right.
no issue because I think the token will be passed in the tab context,
Right.
in the private discussion in another way. But when you are in the desktop application, you need to push an adaptive card or login card for the user to log in to the bot or delegate the credential. And it's complicated because if you want to have a one authentication experience for user, it's complicated.
Yeah, I know. Yeah, so the question is about,
Sorry,
I'm going to rephrase it. When are you going to get off your butts and support single sign-on for tabs and bots? Yes,
Correct.
we're finally working on that. So we actually are announcing single sign-on. It should. I'm going to be talking about it in my talk tomorrow. We have single sign-on for tabs, very close to being, very close to release, or at least in preview. I'm going to be talking about that tomorrow, and we're also working on it for bots, although that's going to come a little bit later. But we're working on both.
Amazing.
Yes.
And sorry for my English, I come from France.
No.
Thank you very much, bye-bye.
No, it's very good.
Hi, Bill.
Yeah, I guess you're next.
Yeah. Thank you for a wonderful session. I'm hoping you will get the slides, right?
I don't know if we might be able to. It depends.
Yeah, because all presenters upload them. So, and this is a fantastic material. So,
good.
Yeah. So we'd love to go back and.
At least a couple of the slides will be in the blog post later today or
Yeah.
Awesome.
Yeah, we haven't given out this super broadly, but you come talk to us.
Okay. Thank you. So my question is now regarding the Teams client itself on desktops. Today, many of our users complain about the memory hog.
Uh-huh.
That it consumes a lot of memory,
Yes.
and they all hear about it.
Yes.
Even though we talk about how the electron architecture is, and we try to tell people, hey, that's how it's designed, right? But then users are like, hey, anytime if I see my memories hogging, I go on my laptop and I see Teams is the one, right? Yeah. So what are you guys doing about it? This is a big.
We are working on that. As I mentioned, the client code base is being rewritten. And it's being rewritten in large part to reduce memory overhead. So we have heard that. We've actually made a fair amount of progress in both performance and memory usage, even over the past year and a half or so. But we are also, we're basically rewriting the client in part to reduce its memory load. We've heard you.
So do you know when we're going to get the new client then?
Oh, it'll roll out gradually. Some of the features are actually there in preview already. I don't actually know which ones we've demoed. I always have to be careful because I never know when anything's really out there. But some things are actually out there, and so you'll be seeing improvements shortly. I'll just briefly one of our most requested features, one for Skype for Business, is the ability to pop out a chat in a separate window.
Yeah, we saw that.
Right, and for us to do that in the old architecture would have just used up more memory, and so we're doing that in such a way that it does not use a lot more memory, and it's actually pretty fast. It's fast.
Awesome. Thank you.
Yes, sir.
My question is regarding the client. In regards to the low-level open source functionality that you guys are using, how do you guys handle when there's a vulnerability in one of those?
Oh, yeah.
Those low-level tools, as far as notification, so we can evaluate any kind of attack vector to decide whether or not that's.
Well, we don't. If there is a vulnerability in an open source component, we treat it as basically a live side issue, and it's fixed in whatever the next version of the client. So at any point in time, there shouldn't
no
be
notification in the meantime. I mean, if the fix takes days, how do we know that okay, this is a potential vulnerability on our clients, and remediate that as we see fit?
Well, the vulnerability is we release every week, and we don't have any way to notify people for something that's going to be fixed, inside of a week, and for the most part, the open source vulnerabilities are not the ones that's just a fraction of the places that can cause problems.
Absolutely. I'm just curious, is that something we need, assuming that we have a high security bar, is that something we need to keep track of?
So our assumption
Is there a list
historically
of
has
those
been,
open source
our assumption has been no, it's not, because we fix things, that's why we release continuously. But I can see why, it wouldn't be that hard to, yeah, it's a good question. You can maybe stop by and ask at the booth and ask if there's something, it's not that hard to find out what those components are, and it's all public.
I'd like to second the slides.
What?
Get a hold of the slides. I'd like to second that as well.
Okay.
Thank you.
Yes, sir.
Hey, how's it going, Bill?
Oh, I'm sorry, I'll get to you next.
Great presentation on the architecture of teams. I think that was very informative. I do have one particular question about a feature, the emailing to a channel. We've seen that when you email to a channel, it writes to the SharePoint site,
Yes.
opposed to it writing to the group mailbox, which kind of is preventing us from using that feature in our environment. Are there any?
Why is that bad?
Because right now, when you write it to the SharePoint site, it isn't really considered an immutable record, and if we want
It's considered what?
it's not considered an immutable record unless there's like a compliance tag applied to it, opposed to it being written to Exchange, where in Exchange it is considered an immutable record. So I was just wondering if there were any plans in the future to perhaps maybe write any of those emails that are sent to a channel to the Exchange Office 365 group mailbox opposed to the group SharePoint site.
That's an interesting question. That's the first time I've heard that. We haven't heard that. The reason we don't, why is that we don't use the group mailbox? Oh, I know why. The real reason we don't use the group mailbox is because we wanted to extract the attachments, and the attachments wouldn't, that's the real reason. And we wanted to preserve it so that you could reply to it. We stored the message body just so, in case it was too big, and you could at least be able to view it. But yeah, we wanted to extract the attachments, and so that's why we do that. But the message body itself, that's a good question. Yeah, it's a good question. As I mentioned, I haven't heard that before, but I can see your point. You could just save it, and yeah.
Maybe continue that later.
Yeah.
Thank you.
Yeah.
Hi.
One more.
Are there any plans for expanding on the external user communication? So the guest users, or the B2B customer, or like B2B clients that you're talking to within Teams. Right now, there's no rich text. There's no sharing of pictures, for instance, which is a big thing, and we use it heavily with our client base that all use Teams, and it's email me the picture. So I'm just curious as to, is there any plans of expanding on that to get more rich text functionality out of external users?
Not guest users. Guest users should be able to see pictures.
So cross-tenant.
What? Well, there's the identity bit, but just the guest users, they should be able to see pictures. I mean, you're a guest user and, yeah.
Well, they wouldn't be a guest user in ours. We're just, let's say you're in a different tenant. I'm messaging you, for instance. And you don't see pictures. Is there any plans for?
When they're messaging you?
Yeah, if you're a federated user, external guest user, you don't have a profile picture.
Oh, the profile picture.
Not just the profile pictures, but sharing rich text between, if you're just doing a one-to-one chat.
Yes, that is actually being rolled out right now. So rich text and one-on-one messages with external users.
Yes, that was my question. Okay.
Oh, that's why. That's why I thought it already worked. I never.
You've been working for y'all.
It's been working, yes.
Perfect, thank you.
My apologies. Yeah. Well, I've run in Ring 1.
So I'm curious, are
You're going to
you,
be kicking me out pretty soon.
um,
Oh. Yes.
so currently right now, anyone can restart a recording of a meeting, like a Teams meeting. Is there ever a thought to only allow the person that scheduled the meeting to start the recording? So we have like senior executives that don't want someone that's listening to them present on a meeting, start that recording if they don't want it recorded.
Yeah, that makes sense. It's a good question. I haven't heard that question. I would think that would have been on user voice. That's what I would do. I would ask, that'd be a good one to ask on user voice. I think it's a good one. It makes sense. It begs the question as to how you administer it.
Well, I can't figure out how to turn it off right now, so. Recordings.
The ability of who can activate a meeting recording.
Right now, anyone can start a recording of any meeting,
Yeah,
and we have senior executives that don't want that.
yeah, makes sense. Yeah. Yeah, you could imagine it being just a setting on the meeting.
Well, the downfall is we end up using other platforms that takes us away from Teams.
I am at the Teams booth.
Okay.
I have to be there in 5 minutes for my duty there. Let me see if we can.
Yeah, that's a good one to follow up on. Yeah, that wouldn't be hard to do. I think I'm being evicted